Hello, and welcome to Backer Breaks It Down. In this episode, we are going to solve some trigonometric equations. These are a bit more special than the first kind that we solved. Basically, we have solved linear trig equations. Now, we're going to solve some quadratic trig equations. So here are like two examples of trig equations that are quadratic in form. Okay. So when you solve a quadratic equation, you have to factor the equation. And then once you've factored it, you use the zero product property where you set each factor equal to zero and solve. So factoring is definitely going to be a part of solving these trig equations that are quadratic in form. So if the equation's not equal to zero, get it equal to zero. And then if possible, factor. Okay. And then use the zero product property to solve. So what that means is that's when you're going to be isolating the trig function on one side of the equation. And to solve for the variable, you have to ask yourself, where are the solutions? Like what quadrants are they in? Or are they quadrantal angles? You'll know it's a quadrantal angle if it's equal to positive, -1, or 0. That's when it's equal to a quadrantal angle. If it's not, if your trig function doesn't equal 1, -1, or 0, then you're going to draw a reference triangle. Like this reference triangle is going to help you to determine the reference angle. And then you can then find the solutions in those quadrants using our wonderful reference angle diagrams, which we used prior when we were solving linear trig equations. Okay. So problem number 1, we have 2 cosine squared minus 7 cosine x minus 4. So the first thing we have to do is we have to factor. Okay. And so you might find it easier to rewrite it in terms of x. So 2 cosine squared x becomes just 2x squared. Okay, it might be easier for you to rewrite these things in terms of x and to do the factoring. Okay, so I did my factoring. Here's all my work. I got to 2x plus 1 times x minus 4. Now it's time to bring back the trig. So what we really have is 2 cosine plus 1 times cosine x minus 4. So then we solve each using the zero product property. So this is where you isolate the trig function. So I took 2 cosine x plus 1. I isolated it and I got cosine equals -1/2. I took cosine x minus 4, set it equal to 0. I got cosine equals 4. Now cosine equals 4 is not possible because cosine cannot equal anything bigger than 1 or smaller than -1. Cosine of -1/2, I know that cosine is negative in quadrants 2 and 3. And then I need to draw my reference triangle to see what my answer angles are. So if cosine, and maybe I guess I'll draw this for you. Remember, keep it simple. Keep it to quadrant 1 to help you see what the reference angle is. Cosine's the adjacent over the hypotenuse. And so you can see that right here. The adjacent is 1, the hypotenuse is 2, and this is happening with a 60-degree reference angle. So since I know cosine's negative in quadrant 2 and in quadrant 3, and it's a 60-degree reference angle, I know my answer angles are 2 pi over 3 and 4 pi over 3. And those are my solutions. So we want to factor. We want to use our zero product property to isolate the trig function. And then from there, we can determine where are our solutions and what are our solutions. So problem number 2, this is a special factoring problem for sine squared minus 1 equals 0. And so you'll notice that I factored it because it's a difference of 2 squares. So the first term and the last term are both perfect squares, and these can be factored where like, oops, a squared minus b squared becomes a plus b, a minus b. So 4x squared minus 1 becomes 2x plus 1 and 2x minus 1. Bring back the trig. So my two factors are 2 sine plus 1 times 2 sine minus 1. Next up, zero product property. So set each of these equal to 0 and solve. That's what I'm doing to get that sine of x is 1/2, is I'm taking 2 sine of x plus 1. I'm setting it equal to 0. So I get that 2 sine of x is equal to negative 1, and thus sine of x is equal to negative 1/2. That's what I'm doing when I'm using the zero product property. So then you have to figure out where are the solutions. Well, sine would be negative in quadrants 3 and 4, and sine would be positive 1/2 in quadrants 2 and 4. So you know what that means. Yeah, I technically have two reference triangles that I'm working with. Okay. But both of them are 1/2. Okay, so one reference triangle because sine is opposite over hypotenuse, and we see that here with our 30-degree angle. So sine is negative in quadrants 3 and 4, which means 7 pi over 6 and 11 pi over 6 are the solutions to this half of the problem. So 7 pi over 6 and 11 pi over 6. And then when it comes to the second half of the problem, sine is positive in quadrants 2 and 4. That's not right. You know it's 2 and 1. 1. So that would be pi over 6 in quadrant 1 and 5 pi over 6 in quadrant 2. So it's all four of these angles. That's what the solution is. So we factor. We use the zero product property to isolate the trig function. We ask ourselves, where are the solutions? And then finally, what are these solutions in those quadrants? And that's how you can solve trigonometric equations that are quadratic in form. And that's how Backer breaks it down.